Welcome to Study Loop.
Hello everyone, today we're doing chapter 19, problem 34. This problem asks us to determine the letter compounds in each of the reaction sequence. So let's start with A. So in A, we see that we have a cyclohexane with a alkene bond, and we're adding boron to it. So we know that boron will add to the least sterically hindered side. And then once we add this hydrogen peroxide, these oxidizing agents, we will convert this BH2 into an alcohol. So what we get is an alcohol addition onto the least substituted carbon, giving us product A. So you break the double bond, and we get an alcohol on the least substituted carbon. And now, chromium, what that does is it's an oxidizing agent. So we're going to fully oxidize this primary alcohol all the way up to carboxylic acid. So we're just going to form the carboxylic acid form of A, fully oxidizing it without changing the number of carbons, without doing any change of the numbering, just converting this alcohol all the way up to a carboxylic acid. Now in B, we have an alkyne. This alkyne is going to be deprotonated by sodium amide, which is going to pick up this proton, making this a carb anion, which can then do a backside 180 attack on our electrophilic alkyl halide to yield us compound C, which is now an extra carbon being added to one side of our alkyne. Now we're taking C, and we're also taking sodium amide again, and now sodium amide is this time going to deprotonate the other side to make a carb anion, which can then attack this alkyl halide. So we have one carbon here, and we get two carbons on this side. And now we're taking ozone and water, which is going to do ozonolysis. And what that does is that it is going to cleave in between this triple bond, oxidatively cleave through this triple bond to give us two carboxylic acids, one having one carbon, one having two carbons. So E will have that one carbon, carboxylic acid. F will have the two carbon, carboxylic acid. And now let's see for C. So C, we have a benzene ring, and we have an alkyl halide and a Lewis acid. So right off the bat, we can see that we are going to do Friedel-Crafts alkylation. So we're going to add carbon-carbon bonds, specifically this isopropyl group for G. And then we're going to go through oxidative cleavage using KMnO4. And KMnO4, what is it going to do? Is going to oxidatively cleave at the alpha position, being carbon number 1. So we're actually going to cleave around here just to leave that carbon 1 on the benzene ring. We're going to leave the alpha carbon, and we're going to get a carboxylic acid using this carbon and losing those other two carbons using KMnO4.